Alright, tonight let's look at parallel and perpendicular lines. Remember that we have looked at lines with slope-intercept, y equals mx plus b, where m is my slope and b is my y-intercept. If you think of a graph, your slope is your rise, or your change in y, over my run, which is my change in x. My y-intercept is the point at which it intersects my y-axis. And again, my slope is the distance up and over from one point to the next. And I connect them with a line. And to find that equation, this is slope, intercept, form. I also looked at standard form, where I have something like ax plus by equals c. And I looked at how I could move this around by subtracting my ax from both sides to get by equals c minus ax divided by b, and you get your y equals mx plus b. It just looks a little bit different. The other option, and the third equation I have, is my point-slope form, where I'm given a point like 2 and 1, and I have to put it into this, where y minus my y point, in this case 1, equals my slope times my x minus my x point, my 2. So you're going to get something that looks like this. And again, even here, I can rewrite it so it's in the gold standard slope-intercept form by adding 1 to both sides, and I get y equals mx minus 2m plus 1. And normally you have an m that is something like, oh, let's say my slope is 3. 3x minus 2 times 3 plus 1, y equals 3x minus 6 plus 1, or y equals 3x minus 5, and it's in slope-intercept form. So all three of these can go back to a form that I can graph in, and they're all related to each other. It's just that this one helps me with word problems. This one helps me graph a line when I know only a point and a slope. And this one is what enables me to graph a line or define a graph and turn it into an equation. All right, so now let's look and see if I can figure out parallel lines. Lines are parallel if they have the same slope and different y-intercepts. Slope is the same, slope is my m, and they have different y-intercepts, different b's. So if I'm thinking of y equals mx plus b, my m is going to be the same for parallel lines. My b's are going to be different. So let's take these two equations, y equals negative 1/3 x plus 5 and 2x plus 6y equals 12. Let's make sure that we get them both into y equals mx plus b form so I can identify slope and y-intercept really easily. Let's come over here and let's look at this one, 2x plus 6y equals 12. I need to solve it for y, so I have y by itself. So I'm going to have to take 2x and subtract it from both sides. And I'm going to get 6y equals 12 minus 2x. That's not so bad so far. I'm now going to end up dividing by 6 on both sides. Y equals 12 minus 2x over 6. Okay, well, remember that you can split your 6 up. So this is the same as 12 divided by 6 minus 2x divided by 6. Let's simplify and rearrange. So 12 divided by 6 is 2. And 2 divided by 6 is simply 1/3. And I need to get it into mx plus b, so I'm going to rearrange a little. And I'm going to move this whole guy up. Remember to keep your negative. And I'm going to move him back here. So I get y equals negative 1/3 x plus 2. Looking at my two equations, what do I notice about my m? M is negative 1/3. What's my b over here for this one? Positive 5. Come back to the problem we solved. What is my m? Negative 1/3. What is my b? 2. These are parallel because they have the same slope and different y-intercepts. Let me show you this on a graph. All right, let's graph this guy first. So my y-intercept is my 5. That's right here. And its slope is negative 1/3. So I'm going to go up 1 and to the left 3. And up 1 and to the left 3. And I'm going to go down 1 and to the left 3, or right 3. And down 1 and to the right 3. So I end up with a line that looks something like this. And I'm going to graph the next one as my x-intercept is 2. So that's here. And its graph is negative 1/3 as well. So it's going to go up 1 and to the left 3. And up 1 and to the left 1, 2, 3. And up 1 and to the left 1, 2, 3. So cool. Down 1 and over 1, 2, 3. Down 1 and over 1, 2, 3. And this guy's line looks something like this. Notice that these are also parallel. They are never, ever, ever going to intersect because they have the exact same slope. They just intersect the y-axis at different places. So just to review, lines are parallel when they have the same slope but different y-intercepts. All right, let's say now that I give you an equation, I tell you it's parallel, how can I write the equation for it? All right, let's say I tell you to write an equation for the line that contains this point here, 5, 1, and is parallel to this equation. Knowing that my parallel line has to have the same slope, but a different y-intercept, then I can figure this out. Let's think about this. Which equation do I want to use? Let's come back here and review. I have 3 different ones. If I know a point and a slope, which equation do I want to use? Well, this one doesn't work unless I know my y-intercept. This one works better with word problems. So that just leaves this one. And look, all I need to use this is a point and slope. So let's use this equation. So coming back over here to my word problem, if I want to write an equation for the line that contains 5, 1 and is parallel to this, then I'm going to use my point and my slope form. Of y minus y1 equals m times x minus x1 to find my equation. So y minus, what's my y1 given? Well, it's 1, equals my m. How do I find my m? Well, I know that parallel lines have to have the same slope. So my slope for this guy is 3/5, and that has to be my slope here. Okay, let's plug my x in. My x for my point here was 5. Hopefully you got that. It should not be 5 minus x. It's x minus 5. There we go. That looks better. All right, let's end up doing distributive property. Moving my negative 1. So I get 3/5 times x minus 3/5 times 5. Okay, let's simplify this. Hopefully you recognize that my 5's cancel out. So I get y minus 1 equals 3/5 x minus 3. Oh, that suddenly looks much easier. Add 1 to both sides. Y equals 3/5 x minus 2. I've got a solid equation. And my slopes are the same, and my y-intercepts are different. So this line is indeed going to be parallel to this line. They will never, ever intersect. It's your turn now. On your own, using the examples that we've done, I would like you to tell me, are the graphs of negative 6x plus 8y equals negative 24 and y equals 3/4 x minus 7 parallel? Why or why not? You can't just look at this and tell me. You need to justify using my definitions from up here. If you can't see it or need to review, go back and rewatch. Number 2, write an equation for the line that contains this point and is parallel to this equation. Notice that in neither of these do you have to graph. If it would help you to graph number 1, you may, but you do not have to. Ultimately, you are going to be using your formulas that you learned a couple weeks ago and using them to complete these problems. These are just like the 2 that I just did. If you have questions on these, copy these down and go back and rewatch the video.